Another idea that we want to become comfortable with, we can express in this example. So let's say I have 2 to the x to the fourth. Notice that I have two different elements within its base. So what does that mean? Well, that means 2 times x times itself 4 times. And then if I rewrote that, I could rewrite it as 2 times 2 times 2 times x times x times x times x, or our shorthand is 2 to the fourth times times x to the fourth. So what does this suggest? It suggests that we have a product to powers rule. So let me write a product to powers rule, which says that if I have some, let's see the right terminology right there, some a and b. So let's say if I have some a and a b, I want to raise that to the nth power. Well, this becomes a to the n times b to the n. It's kind of a distribution property I'm using for exponents. So let's look at a couple examples and see how we can work that through. Example, 5x cubed. Now remember, we have to pay attention to what the exponent's base is. Since we have parentheses guarding all these terms and its base is the entire 5x. So that means that we can use a product of powers rule and make this 5 to the third times x to the third. 5 cubed is 125. X cubed is x cubed. So there's an example of the product of powers rule. Let's look at negative 2y to the fourth to the fifth. Notice we have a couple of things going on here. My base of the fifth is negative 2y to the fourth. I have y to the fourth in here. So this exponent is going to get distributed to both of these terms. So it's going to become negative 2 to the fifth times y to the fourth to the fifth. Let's clean that up. Negative 2 to the fifth, 2, 4, 8, 16, 32 is a negative 32. And then y to the fourth to the fifth, I need to go back and remember my powers rule, which means I can multiply those exponents, and it's y to the 20th. So negative 32, y to the 20th is the simplification of this original expression that we showed.